The keywords here. Volatile. Or certain semi-volatile. Can you see it? Can you see it? Okay. The volatile or semi-volatile organic compounds. Okay, from contaminated groundwater or surface water. So this contaminates contaminated waters contaminated waters enter from the top. Okay, enter from the top. And airs, the clean airs, okay, blow in from the bottoms. Okay? And waters flow downwards due to gravity, right? Water flow from downwards and air flow upwards, right? It's a counter current. So it's a counter current flow. Water flow from the downward and air flows upward. So the volatile substance, for example, like carbon dioxide or organic compounds, okay, organic compounds will be transferred from water to air. Okay? Those contaminated materials will be transferred from water, okay, because water is contaminated. And the clean air flow from bottoms. Okay? Okay, so after that, the contaminants. So the air here is no longer clean. Air on the top is no longer clean. Air will be contaminated. So students understand? The dirty waters flow from the top. Okay, from top to the bottom. And the clean air flow from the bottom to the top. So it's a counter current. So later those contaminants substance will transfer from water to air, and the contaminated airs will flow out, will access from the top. Everyone okay? Okay, you can put the keywords here. Oh. So this is contaminants. This is contaminant. This is clean. And the clean water out here. So we can use this so-called airstream towel to purify contaminated water. Understand? This is very useful to remove volatiles and semi-volatile. Semi means half. Semi-volatiles organic compounds. Okay, let's do discussions. So an air stripping similar to the shown in the previous slides, okay, is used to remove the dissolved carbon dioxide gas. So the carbon dioxide dissolved in the water. Okay? So we try to remove carbon dioxide from the groundwater supply. If the towel lower label twice the equilibrium concentrations, what amount of the dissolved gas will remain in the water after treatment? Okay? And also, the log, okay? They give you some, the log of the 0. So this, you might know this, right? The log 3.5, okay? Okay, the log of 3.5 times minus 4. Okay, this is very close to 3.5 as well. Okay, if you don't have calculator, but if you have calculator, you don't need to worry. So therefore, the partial pressure of carbon dioxide is 10 to the power of minus 3.5. Okay. So first off, what kind of principle we might use in these questions? Okay? And I'll give you 1 minute to think about these questions. Please practice. Please think. Okay? If you know this question, when you get back home, you don't need to review. Or you can just take a quick reviews before the exam, right? Please understand all the concept during the class. So first of all, you need to identify what kind of principle that you are going to use in this system. All right. Anyone? What principle we are going to use? One second. Okay. Remember what principle you might use for these questions. What principle we learned before. What do you think? Something regarding partial pressures and the gas dissolved in the water. Okay, it's fine, okay. So it's Henry's law. So we are going to use Henry's law, okay? So C equals KH, just put K, okay? KH, H stands for Henry's law, and times partial pressure of carbon dioxide, right? So the KH, what we got for KH? Okay, sorry, I didn't give KH. So you need to find out, rewrite this one down, okay? But during the exam and for the assignment, I will give you KH. Okay. So you need to find a table. The KH for the table is 10 to minus 1.5. Okay. So it's 10 to minus 1.5. So from tables. Okay, keep this one in mind. For our final exam, I will do open book. Okay? So the informations that contain in the textbook, I don't need to provide. Understand? 那个考试的时候是开书考，所以如果有些资讯呢，课本有的我就不会提供。Okay? For example, like these questions. Okay? In the textbook, it got some table for Henry's law constants. right? So the catch here is 10 to minus 1.5. This is from table. And the next is the partial pressures. Okay, the partial pressures. So the question already told us. So it's 350 ppm. So which means 350 ppm, which means this equals 0.00035 ATM. Okay, and log 0.00035 is close to minus 3.5. As the question told you. So the partial pressure of carbon dioxide will be close to 10 to minus 3.5 atm. We write this one down. So this we have 10 to minus 3.5 here. We have 10 to minus 3.5 years. Okay, so the answer will be the answer will be 0.44 milligrams per liters. So, but this value is at equilibrium. This value is at equilibrium. Okay, so after treatment, the question is here. After treatment, the tower lowers the level twice. Okay. Student, please underline this. The tower lowers the level twice. Lower the level twice the concentration. Lowers the level, so the concentration should increase. So this is before. This is concentration before treatments. So after, because the question mentioned here, the tower lowers the level twice the equilibrium value. So it's going to be 0.44 times 2. So the answer will be 0.88 milligram per liter after treatment. So Henry's law can be used to determine equilibrium concentration. Please write this one down. So you need to find out the equilibrium concentration first, which means before the treatment. Okay, and the question will tell you what gonna happens after treatment. For example, like this questions, it say that, for example, like this question, it say the towel is going to reduce the concentrations to twice the equilibrium level. So after treatment, the answer will be 0.88. Okay, everyone? Okay, and this is also something you need to know. How to find out the partial pressure. Okay, so this is very useful for wastewaters. Wastewaters. Okay, although you might say that the water is in the environmental engineering one, but the problem is in environmental engineering 2, we are also going to deal with some wastewaters. Okay, come from the household. Okay, or the waste chemical from the industry. Okay, so next I would like to introduce this so-called anaerobic digester. Okay, so the An here is negative. The An here is negative, which means without. And aerobics means oxygen. So anaerobics means without oxygen. Okay, 无氧的这种 digester. Okay. So no oxygen is present here. Because not all the living things require oxygen. What happened? Some microorganisms do not need oxygen to survive. Okay. They might even die if you provide oxygen to them. Okay, so we can use some bacteria. Okay, we're gonna mention this later. Okay, we can use some bacteria. They do not like. They hate oxygen. Okay, and this kind of bacteria can be used. This kind of bacteria can be used to break down organic matters. So previously, air strippings, we use clean air to transfer those organic matter, right? Especially volatile organic matters. But in this device, we use some living organisms, bacteria, 这种厌氧菌. The bacteria do not like oxygen to break down organic matters. And the good thing is, after that, they can produce some burnable biogas. 一些可燃烧的生物气 biogas, such as methane, which we can use that for natural gas, right? So this biogas, such as methane, can be used as an energy source. Okay, so you can see that some wastewaters, okay, we can say this one stone kills two birds, right? One stone is 12两. One stone kills two birds, right? We can use that to treat wastewater. And the gas can also be used as an energy source. Okay, but we need the help from those anaerobic materials. Okay, so where the anaerobic bacteria, okay, put bacteria here. Anaerobic bacteria. Oh, no. You only got temporary here. So where the anaerobic breakdowns of organic matter separates. And those anaerobic microorganisms convert organic matter into biogas, which can be used as an energy source. Okay, everyone? Okay, I would like to move on to discussions. So in these questions, anaerobic digester is commonly used for wastewater treatments. But this is some kind of biological process produce both carbon dioxide and methane gas, and we call them biogas. Okay? A laboratory workers plan to make a synthetic digester gas. There is currently 2 liters of methane gas at 1.5 atm and 1 liters carbon dioxide at 1 atm in the lab. If these 2 samples are mixed in a 4 liters tank, what will be the partial pressures of the individual gases? And the total pressure, what is the total pressures? So what principle are we going to use in these questions? I don't know. Okay, and next one. Adina, it's Adina, right? Adina. What do you think? What principles or what theories we can use for this question? Just one question. Can we still use Henry's law? Can we still use Henry's law? What do you think? Can we still use Henry's law? Can we still use Henry's law? I don't think so. Because in this question, we didn't see any dissolved concentration, right? So what principle? Let's take a look. So we can use the ideal gas law, right? So especially like P1 V1 equals P2 V2. I think this is so-called Charles law. Let me check. No, this is not Charles. I think this is Boyer's law, right? Yeah. So we can use this one, P1 V1 equals P2 V2. This is so-called Boyer's law. And the Charles law, Charles is V1 over T1 equals V2 over T2. Okay, it's Charles because he is the British. Okay, so not Charlie. If he was American, you can call him Charlie. Okay, Charles law, and another one is Gay-Lussac. Gay-Lussac. Gay-Lussac, G-A-Y. He is not a real gay. Okay, he was not gay. That's his name. Okay, Gay-Lussac. 2 persons. One is gay. The other one is Lussac. Okay. So P1 V1, P1 over T1 equals P2 over T2. His last name is Gay. Okay. Okay, so in this question, we're gonna use Boyer's law. Okay, so P1 V1 equals P2 V2. So you can find out the P2 equals 0.75. P2 for methane. And P2 for carbon dioxide is 0.25. And the total pressure, you just add it up. Okay, you add it up as one. Okay. Okay, so as I mentioned in our first class, I said the environmental engineering actually is interdisciplinary subjects. So we need knowledge for mass balance, and you also need to know. We also need a little bit reaction kinetics. For example, like first order reaction, second order reaction. Okay, and also you need to know a little bit about